In our previous video, we looked at finding the area of this triangle, right? But we're going to do something else now. I have plotted the graph of y equals 0.5x and also y equals 1.5x in GeoGebra. Here we have it. Now, this is the line x equals 5. In this case, you're being asked to find the area. Let me write it down here. The area bounded by x, y equals 1.5x, y equals 0.5x, x equals 5. All right. Now the thing is, you could very well use half base times height to work this out, you know. Because if you consider the half base times height with the 1.5x, and then the half base times height with the 0.5x, and you subtract them, you get this shaded area, right? We could do that. We'd have to find out where they actually intersect. We know they intersect here at 0, 0. But what is this point here? Well, x is 5. So 0.5x is equal to 0.5 times 5, which is 2.5. So they intersect here at 5, 2.5, and 1.5x. They would intersect at 1.5 times 5 would be 5 plus 2.5, 7.5. So if you should use that method and say half times the base, which is 5, times the height, 7.5 for this one here, minus half times the base, which is 5, because remember the base is the width from here to here, times the height, 2.5. What would we get? We could just work it out quickly with our calculator and see what happens. Okay, so here we have our calculator. Half, which is 0.5, times 5 times 7.5, minus 0.5 times 5 times 2.5, 2.5 equals, I get 12.5, right? 12, let me rewrite that, my 12.5 units square units. But anyway, what we want to do is use double integration. Want to use double integration to find it. So how do we do that? Well, we see that if we take some squares and stack them up from floor to ceiling, we'll be going upwards from where to where. That's the thing. It is from x from y equals 0.5 to y equals what? 1.5. You can see that. So this is y equals 0.5 up to y equals 1.5. So we're stacking up y's, the heights. Remember the little squares, the height is a change in y and the width is a change in x. So we're summing up from y is equal to 0.5 x to y is equal to 1.5 x, and we're stacking up height, so it's delta y. After we stack up, we pack from floor to ceiling certain heights, we need to go sideways, so we stack them upwards and then to the right. So we need to add up these, and we add them up from 0 up to 5. So x is going from 0 to 5. You see that? So in this case, we're summing up all of this. We're summing it up from x equals 0 to x equals 5. And we're summing up delta x's. All of these widths. Okay? Now, as delta x tends to 0 and delta y tends to 0, that means those small squares that would fill up the area, they get smaller. So we need more and more of them. And as the dimensions tends to 0, the number of them tends to infinity. So we integrate from 0 to 5. This kind of look like y is 5. And this the y now integrate from 0.5x to 1.5x of not delta d, dy dx. Remember there's a 1 here. Now, of course, 1 unit of area, whatever that is. But anyway, when we integrate 1 with respect to y, we get y. So this is y, and the boundaries are from 0.5x to 1.5x, and we're integrating from 0 to 5 dx. So we're doing this integration first, and then all of this one. Alright? So what you have is 1.5 x minus 0.5 x, and we're doing it from 0 to 5 dx. Good. Now you have 1.5 minus 0.5 is what? 1x. So you're integrating from 0 to 5 of x dx. Alright? Now when you integrate x, you get x squared over 2. And you're going from 0 to 5. So this will be 5 squared over 2 minus 0 squared over 2, which is just 5 squared over 2. 25 over 2 is what? 12.5 units square. Is that what we got up here with the half base times height? Right, 12.5. So it's 12.5 square units. Alright? So that's it for this video. I'll see you in the next video.